well, in the previous video I have just explained the question. So this is the part 2 of the video for the equations of motion. We are dealing with number 3. In the previous video I have explained the question, and this is the solution of number 3. If you haven't watched that video, please watch it till the end and you'll understand the question. So number 3, here the first thing which is given to us is velocity, which is 30 km per hour, and you are supposed to find the acceleration in meter per second square. Hence this 30 km per hour needs to be changed into meter per second. So as you all know, we have done in exercise 2a also how to change the speed into how to change the units of speed. So here I am multiplying 30 by 5 upon 18 and getting the answer as 8.33 meter per second. And the first case, the second velocity after 2 seconds, it becomes 33.6 km per hour. Again, converting that velocity into meter per second, I am getting 9.33 meter per second. So here I am supposed to find the acceleration. So whose value comes from the formula A equals to v2 minus v1, which is the final velocity minus initial velocity upon time. So putting those values, which are 9.33 meter per second minus 8.33 meter per second upon time, which is 2 seconds. So after I subtract those two values, I'll get 1 upon 2, which is the denominator, meter per second square. So yes, meter per second square. So again solving that, I am getting 0.5 meter per second square, because half means 0.5 meter per second square. This is how I get the acceleration in the first case. While in the second case, my velocity changes from v2 to v3, which is from you can see the v2 is 9.33 meter per second to 37.2 km per hour. Again, I have to convert this 37.2 km per hour into meter per second. Again, I have to multiply by 5 upon 18 and I am getting the answer as 10.33 meter per second. So again, using the formula of acceleration, which is final velocity minus initial velocity upon time, 10.33 meter per second minus 9.33 meter per second upon time, which is 2 seconds. So again I am getting half meter per second square, which is 0.5 meter per second square. Since both the time we are getting the same acceleration, which is 0.5 meter per second square, just missed a square here, 0.5 meter per second square. So the acceleration should be uniform. So this is number 3. So if you want to go to the next number, which is number 4, the question reads as: a body initially at rest starts moving with a constant acceleration of 2 meter per second square. That means initial velocity u is 0 again, like number 1. Again the acceleration is given. Calculate the velocity acquired. In the previous cases, like number 1 and number 2, we were finding out the distance covered, but here I am supposed to find the velocity, and number 2 will remain same, which is the distance traveled in 5 seconds. So please pause the video and try to solve number 4 as well using the equations of motion. So how will you solve the first case, that is the velocity? So which formula will you be using? Will it be AC equals to ut plus half at square? I don't think so, because you're finding the velocity. So it should be v equals to u plus at is the time given to us. Okay, they are telling us in 5 seconds. So I've just solved this number 4 here. So please try to solve by yourself, and if you cannot solve, I've just completed here. Standing on the paper. Okay, number 4. Okay, number 4. So the question reads as, the solution reads as u equals to 0, because the initial velocity was 0. Acceleration is 2 meter per second square. Again I missed the square here. And time equals to 5 seconds, and I'm supposed to find the final velocity. using the formula v equals to u plus at. So v equals to u plus at, again replacing the values of the initial velocity, acceleration and time. This time using the units as well. So 0 plus 2 meter per second square multiplied by 5 seconds. So the units have been cancelled, like 1 second goes and the square goes, and v equals to 0 plus 2 into 5 is 10 meter per second. So my final velocity is 10 meter per second. So number 2, I'm supposed to find the distance covered in 5 seconds. So to find the distance covered in 5 seconds, so I'm supposed to use the formula s equals to ut plus half at square, which is like number 1 again. So again replacing the values of u, t, a and t square, I'm getting s equals to 0 multiplied by 5 seconds plus half 2 meter per second square multiplied by 2 meter per second square into 5 seconds into 5 seconds. So again seconds gets cancelled and meter remains here. So 0 into 5 seconds gives me 0 plus 2 into gets cancelled. So 5 into 5 is 25 meter. Hence my displacement comes up to